physical science or chemistry, you've talked about density. There are just a few details that I want to talk about in the mathematical context. They're going to put a few twists in there. Okay, they're going to put a few twists in there in the mathematical context with density. But it's still the same thing. Density is equal to the mass divided by the volume. Okay, the really easy way to remember that is DMV. Okay, it's like the division of motor vehicles. You go to get your license. DMV, density equals mass divided by volume. So the equation is very, very simple, but sometimes we're going to have to do a little bit more work before we can use the equation. So for example, and I wouldn't write down all these words. Okay, I would not write down all these words, but let's just write down the important things that we need. A cylindrical piece of wood, probably if they tell us the shape, probably has implications in the problem. Okay, a cylindrical piece of wood has a diameter of 2 feet, a height of 5 feet, and the cylinder has a mass of 600 pounds. They want to know the density of the wood to the nearest pound per cubic foot. Use 3.14 for pi. So the first thing that I notice is if they tell me to use 3.14 for pi, that probably means somewhere in the problem I'm going to need to use pi, right? All right, so let's look at the units of density. It says nearest pound, so that's good. Our mass is in pounds, so M equals 600. We've got that part. Per cubic foot, so that's foot cubed, okay? So that means that's our volume. They didn't give us the volume. They did not give us the volume in this problem, but they gave us enough information to figure out the volume. So first of all, they tell us it's a cylindrical piece of wood. So what is the volume formula for a cylinder? Use your formula sheet there. Pi r squared h. Okay, pi r squared h. So they tell us to use 3.14 for pi. We need r. We need the radius. Did they give us the radius? No, they gave us the diameter. So if we know the diameter, the radius is half of it, right? So if the diameter is 2, the radius is 1 foot. So that's times 1 squared times the height. They gave us the height. That's 5. So then we just need to crunch those numbers right there. 3.14 times 1 squared is 1 times 5. So our volume is 15.7. Now, it's in the middle of the problem. It really doesn't matter, but I do want you to be in the habit of labeling things with units when they have units. So volume is always in cubic units because we have 3 dimensions to volume. There's always a depth, a height, and a length, or a width, however you want to look at it, to volume. So it's always in cubic units. In this case, feet. All right. And then that's another way to help you keep the density formula straight. Like they tell us the density is in pounds per cubic feet. So that means pounds is going to be on top. The 600 is going to be on top. And the cubic feet, the 15.7, is going to be on the bottom. So let's divide 600 by 15.7. And it wants it to the nearest pound. So our density here is approximately 38 pounds per cubic foot. Okay, so that one pretty easy. The only thing we had to do was compute our volume. Now this next one, a little bit more to it. Okay, the next problem says block A and block B have the same mass, but the density of block A is twice the density of block B. Identify the possible missing dimensions of block, that should say block A. There may be more than one combination of answers that work. All right, so when we look at the diagram, block A, we only have the width of that block. Block B, we have all of its dimensions. So if we have all of its dimensions, we're dealing with density. That means that we can find its volume, and that's probably going to be helpful to us at some point in time in the problem. We've got 6 times 5 times 12, so that's 30 times 12. That's 360 cubic centimeters for the volume of block B. Okay, the volume of block B is 360 cubic centimeters. All right, well, that's all that we can figure out for sure at this moment. So let's go back to what the problem says. It says block A and block B have the same mass. So here's something that you can do if you come across a problem that does something like this. They tell you that they have the same mass, but they don't tell you what the mass is. Well, you can just make up a number, okay? We could use a variable, but we're going to have other variables in the problem, so that might get a little confusing. So let's just make up a number. Let's say that they have a mass of 500. They don't tell us what, so we'll just leave it with 500. Okay? They don't tell us grams, pounds, whatever. We'll just leave it at 500 for the mass. That's the same thing for A and B. All right, but the density of block A is twice the density of block B. So let's set up, we can find the density of block B now, right? We can find the density of block B. Density, I'm going to put a little subscript of a B there so that I know that it's the density for block B. It's mass divided by volume. Okay, so let's see if that simplifies. It does not divide evenly, and it's not a terminating decimal, so let's leave that in fraction form so we don't lose anything. Okay, the density of block B is 25 over 18. Well, what else do we know? We haven't used this piece of information right here. The density of block A is twice the density of block B. So if we multiply the density of block B by 2, we're going to end up with 25 over 9. That is equal to the density of block A. So the density of block A, the mass is 500. It's the same mass. We don't know its volume. How can we solve that equation? Fraction equal to a fraction, what do? Cross multiply and divide. Okay, cross multiply and divide. So 9 times 500 is equal to 25V. Divide both sides by 25. So we've got 4,500 divided by 25 gives us 180 for the volume of block A. We know one of its dimensions is 6. So what does that leave us with for the other two dimensions? 30. So 30 total, right? Is the width times the height, or the depth times the height, however you want to look at it. So let's look at our choices. Eden already said 5 and 6. That's one possibility. What else would work? 3 and 10. Okay, 3 and 10 would also work. None of the other numbers will multiply to give us that missing dimension of 30. Okay. So this one, multi-step here, but if you take the information and just chunk it down into pieces, work with what you know to get something else that you need to know, and then go from there, you'll be able to get to the answer. Okay, let's look at 2 more examples here with density. A certain type of metal has a density of 5 grams per cubic centimeter. A piece of this metal has a mass of 2 kilograms. What is the volume of this piece of metal to the nearest centimeter? So this one seems pretty straightforward, right? They give us density, they give us mass, they want to know volume. We're only missing one part of the equation. What's the twist to this problem? Does anybody see it? Well, we need to know the volume, but do I just plug in 2 and 5? No, why not? Okay, the units are different. We've got grams in our density. We have kilograms in our mass. So we've got to convert kilograms to grams. How many grams are in a kilogram? 1,000. Kilo is 1,000. So that is equal to 2,000 grams. Now we can plug it into our equation. Density is 5. Mass is 2,000. We don't know the volume. Solve this, we multiply both sides by V. We've got 5V is equal to 2,000. So then we divide by 5. So our volume is 400 cubic centimeters. Okay, so you got to look out for things like that. when it seems super straightforward that I just need to plug in the numbers, check and make sure that your units agree, because they like to throw those extra pieces in there. Okay, let's look at one more type of question that you may be presented with here. A carpenter has 2 types of wood in his workshop. He cuts a block of each type of wood. The block of type A has a volume of 60 cubic feet and a mass of 300 kilograms. The block of type B has volume of 100 cubic feet and a mass of 600 kilograms. Which is a correct comparison of the densities of the wood? So when it kind of makes sense if we find the densities to start with. Okay, we've got density of A. Before we do this, let's make sure that all of our units are the same. We can't compare densities of different units, okay? So cubic feet, kilograms. We're good. Okay, so density of A, mass divided by volume. So that simplifies to 5. Density of B, mass divided by volume, 600 divided by 100 is 6. So which one is more dense? B. The bigger the number, the more dense it is. Okay, it does correlate there. The bigger the density, the more dense it is. So let's look at the options here. Type B is less dense. Well, eliminate that. That's not true. Last one, type A is more dense. Throw that one out. Okay. The middle 2 choices, the first part of the phrase is correct. Okay. The second choice says the wood of type B is more dense. That is true. The third choice is the wood of type A is less dense. That is true. So it must mean that there's something wrong with the reasoning, the because statement there. So let's look at the first one. Because the ratio of mass to volume is lower for type B. Does it make sense that it's more dense if the ratio is lower? No, that doesn't make sense. Let's look at the third one and make sure that we haven't overlooked something. Type A is less dense because the ratio of mass to volume is lower for type A. That makes sense. Less dense, lower ratio. Okay, so you just got to pay attention to those details when it comes to this. All right. Now, I don't think any of the problems on the 10 marks today have anything to do with population density, but I did want to mention it because there was a question on the benchmark about population density. Okay, the same kind of logic applies if you're talking about population density, and the units usually give it away. Okay, they're going to ask about what's the population density in people per square mile. Well, then that means you put the number of people divided by the area of land or whatever it is. Okay, look at the unit. If they ask you a question about a density that we haven't really talked about, it's not that mass divided by volume. If they give you units, use those units to kind of tell you how to set up that division problem, how to set up that ratio. Okay, the units are going to tell you. Otherwise, in general, density is going to be your amount divided by, I guess, space is a good way to put it. Okay, whether that space is a volume or an area, whatever it may be, it's always going to be an amount divided by space. Okay.